Today we're going to look at 3 common mistakes students make in Argand diagram questions in Cambridge 9709 paper 3. These questions are actually quite visual and geometric, but students often lose marks because they misunderstand what the expression means on the diagram. So let's look at 3 mistakes that come up very often. The first mistake that students make is to misunderstand the modulus. Now, modulus of z or modulus of a complex number is the distance from the origin. So for example, if you have modulus of 2 plus 3i. Now 2 plus 3i is a complex number. If I mark it here on the Argand diagram, 2 on the real axis, 3 on the imaginary axis, and let's say this is the point, 2 plus 3i. The modulus of 2 plus 3i is nothing but the distance of the point from the origin. So this distance here, I'm going to mark it here on a slant. This is the modulus of 2 plus 3i. And we usually find it by using the Pythagoras theorem. So I'm just going to erase what I drew here. So let's say we are given modulus z is equal to 2. Now here, the complex number z is not given to us, but we are told that its distance from the origin is 2 because the modulus of z is 2. So what does this mean? So there are a whole bunch of points that are at a distance 2 from the origin. And so for example, this point here, this point here, this point here, and this point here, plus a whole lot of points, all of which end up forming a circle of radius 2 around the origin. So the solution for modulus z is equal to 2 is a circle centered at the origin of radius 2. As you can see, modulus could represent a whole bunch of points. Students make the mistake of thinking that it's just a single point. So it depends on the question. If they have given you the value of z, such as 2 plus 3i here, then all you have to do is find its distance from the origin when they ask you for the modulus. On the other hand, if they give you modulus of z is equal to 2, then z represents a whole bunch of points that are at a distance of 2 from the origin. So understanding the modulus and understanding that it represents the distance from the origin makes these questions so much easier. The second mistake that students often make is misunderstanding the argument. Now, what is the argument of a complex number? It is nothing but the angle made when you join a complex number to the origin. So let's say this is the origin. I want to find the argument of this complex number in red, z. So what you need to do is join that point to the origin, and the angle that that point makes with the positive real axis is the argument of the complex number. So the positive real axis is the axis on this side. The negative real axis is on this side. So it's always the angle made with the positive real axis. So let's take the examples of complex numbers in all the different quadrants. So I've drawn them in different colors. So in the second quadrant, I've marked it in green. So for this complex number, if I wanted to find the argument, I would join the point to the origin, and the angle that this line makes with the positive real axis, this angle is my argument. Similarly, in the third quadrant, I've marked it in blue. To find the argument, join z to the origin, and the angle that it makes with the positive real axis would be this. This is the argument of z. And finally, in the last quadrant, I'm joining this complex number z to the origin, and the angle that it makes, I'm drawing here. Okay. Now you have to also keep in mind that according to your syllabus, argument of z has to lie between pi and negative pi. Okay. So if the positive real axis is taken as 0 degrees or radians, then this is pi by 2, and we have pi here. And if we go clockwise, then this is negative pi by 2, and this is negative pi. So all your argument values have to lie within the domain that is suggested by your syllabus, which is negative pi to pi. Students must also keep in mind that the arguments formed by complex numbers in the in the third and fourth quadrants have negative values because they lie between minus pi and 0. The third mistake that students make is misinterpreting modulus of z minus z1. Modulus of z minus z1 appears very often on your Argand diagram questions, and it represents distance of z from a known point z1. Z is an unknown point and z1 is a known point. Now the first mistake that students make here is identifying z1 incorrectly. So let's take an example. Suppose you're given modulus of z minus 2 plus 3i is equal to 2. What does it mean? It means that the distance of z from z1 is equal to 2. Now what is z1 in this? To identify z1, you have to write it in the correct format. So you have to write z minus, open a bracket always, and put the 2 plus 3i inside the bracket. So because there's a minus sign outside, the sign of 2 plus 3i will change. So 2, instead of being negative, will become positive, and 3i becomes negative 3i. Now we can say that z1 is 2 minus 3i. Do you see the possible error that you could make here? So you don't accept the value within the modulus as it is. Remember to put a bracket around it and leave the minus sign outside. Right. So now you want to know, you're given that the distance of z from the point 2 minus 3i is 2. So what does that mean? First you locate the point 2 minus 3i. So this is 2 and negative 3i is here. So negative 3. And this is the point 2 minus 3i. Right. So we want to find a complex number z whose distance from this point is 2. So there's a whole bunch of points that are at a distance of 2 from this complex number 2 minus 3i, and they all lie along a circle of radius 2. So we draw a circle of radius 2, and I'm just making it a solid line. That circle is the solution for this equation z minus bracket 2 minus 3i whole modulus is equal to 2. Students make two errors here. One is they misinterpret z1, and the second is that they assume that all circles are centered at the origin. They are not. So once you identify z1, the circle is centered at z1. So the key ideas to remember are: modulus represents distance from the origin, argument represents an angle with the positive real axis, and modulus z minus z1 represents distance from another point, which has to be identified correctly. Once you understand these geometric interpretations, Argand diagram questions become much easier. Check out our next video, which features common mistakes that students make in complex number questions.